Okay. Good morning, good morning, good morning, everyone. Am I visible, audible? Please check. Please check whether I am visible and audible. Please check. Good morning, everyone. Good morning. Please reply that I am visible or audible. Good morning, good morning, good morning, Pintu. Good morning, Aditya. So, my voice is clear. Am I visible properly? Voice is clear. Voice is clear. Yes. Okay. Thank you, Sham. Thank you. Thank you very much. Thank you, everyone. Audible. Okay. Very good. So we have covered, I think, vernier caliper and screw gauge in last class. We have covered vernier caliper as well as screw gauge. We have covered both the instruments. Okay. So today we are going to start our new topic, but it's general properties of matter. General properties of matter. In general properties of matter, there are elasticity, then surface tension, viscosity. We are going to talk about these properties. So first we are going to start with elasticity. First we are going to start with elasticity. Elasticity. It's a very simple idea, simple concept of elasticity. Why? First of all, why we are learning about elasticity? Let us discuss why we are learning general properties of matter. We all are surrounded by different kinds of matters. Okay, every day we are interacting with some matter. Even now, when I am holding this pen, I am interacting with some matter. I am wearing this cloth. This is made up of a matter. Okay, so my cloth, my pen, everything around us is made up of matter. We are sometimes observing matters is solid, sometimes matter is liquid, sometimes they are in gaseous form. So they have different forms. Sometimes their properties are different. Okay, when we see a page, let me find a single page here. So there is no page available here. Paper, yeah, there is a paper here. Okay, there is a paper available here. So you all have seen papers. You all have seen papers. Okay. If you try to tear the paper, by applying force, see, it's very easy to tear it. It is teared with very small amount of force. Okay. If you try to tear it, it's very easy to tear. But if you try to stretch it, with large amount of force, it's not tearing apart. So this is very different. In this direction, the paper behaves very different, but with sidewise force, it behaves very different. So materials have different properties. This paper has unusual property. You can try to elongate it, it will not break. But if you try to tear it by applying force parallel to surface, then it is easy to tear it. But this pen, if I try to elongate it by applying large force, it is not able to. I am not able to elongate it. Or if you try to compress it, we are not able to compress it. So different materials have different properties. For example, paper has different property, this pen has different property. Clay or mud has different property. If you put your finger to mud, it's easily deformable. So this one, therefore, we can no, this one is going to be asked in the next class. Okay, next test. So this is not for this weekend exam. Okay, so if I try to break this pen, it is hard to break it. But if I have a very soft thing here, let's say some vegetable, it's very easy to break a vegetable apart. Okay, so different material has different properties, and what kind of property are there, what is the types of property materials are having, we are going to study this. So first property that we are going to study is elasticity. Elasticity is a type of property of matter. It's a type of property of matter. It is a type of property of matter. What type of property? What is this property? When you try to deform a body and it tries to resist the deformation and it regains the shape when the deforming force is removed, that property is elasticity. Elasticity is a property because of which material tries to resist the deforming force, or we should say deformation, and regains original shape or tries when force is removed. So when you try to deform a body by some deformation, by some deforming force, and deformation is resisted by the body. I am trying to pull this pen, but it's not very easy to elongate it. It's not very easy. Okay, I'm trying very hard, but it's not very easy to elongate it. So it's trying to resist my elongative force, and as soon as I leave it, it regains its shape. This property is called elasticity. This property is called elasticity. It is not shown by all the material. There are some material which are not elastic. They are called plastic. They are called plastic or plasticity. Plasticity is opposite of elasticity. Opposite of elasticity. For example, clay or mud or mitti. If you have a moist clay and you put your finger in it, it's easily get deformed. You can easily change the shape. It does not resist and it doesn't even regain the original shape. So the material which do not have elasticity, we say they have plasticity. They have plasticity. It's not the same name as this plastic. The name plastic is a type of material, and here we are talking about property of material. So properties of material is elasticity and plasticity. Elasticity means trying to resist the shape change. Plasticity means do not resist the shape change. Is this clear? We are talking about two properties of material, elasticity and plasticity. Okay, why elasticity and plasticity is observed? Only because after applying some deforming force. What is deforming force? The force which try to deform the body. The force which is trying to deform the body. That is deforming force. Due to the deforming force, there is some kind of deformation in the material, and the amount of deformation causes whatever is the amount of deformation that causes restoring force in material. So now we'll learn about restoring force. Restoring force. Whenever there is some deformation in the material, the distance between the atoms or molecules in the material gets disturbed. Whenever I try to squeeze a material, I try to push a material, I try to suppose break this pen by pushing it. I am trying to push this, I am trying to compress this. So if I am compressing it, the distance between the plastic material and plasticity is different. No, the material showing plasticity are called plastic material. The material showing plasticity are called plastic material, and we are talking about property. The general day-to-day word of plastic that we are using, this plane is made up of plastic, that is different. That is different. Okay, so that plastic is different. Here we are talking about property of material. Okay. So what is restoring force? When you try to change the shape of a body or size of a body, the distance between molecule and atom gets changed. And you can imagine the atoms inside a material, the atoms or molecules inside a material are connected with springs. You can imagine a solid material in which the atoms or molecules have some kind of attachments. This attachment is like spring. This attachment is like spring. So these molecules are attached with are attached with springs. So if you try to squeeze them, the distance between them will reduce. If we try to squeeze them, the distance between them will be reduced. And springs are getting compressed. So if springs are getting compressed, they will try to push the atoms apart. So the force generated by spring, it is like a restoring force. It is like restoring force. The force generated within the material after deformation, there is a force generated in the material which is trying to regain the shape of the material or size of the material. That internal force is called restoring force. It tries to regain shape or size of body. This is an internal force. Whereas our deforming force was external to the material. Deforming force is external force which is causing deformation is called deforming force. Due to deformation, there is an internal force generated in the material which is trying to resist the shape change. That internal force is generated because of the interatomic or intermolecular force. That is a type of interatomic or intermolecular force. It is a type of interatomic or intermolecular. See, the atoms are arranged in a regular way in a solid material. Atoms or molecules, if a material is made up of molecule, we will say molecules are arranged in regular way, and the force of attraction or repulsion between the molecule will be called intermolecular force. So the restoring force which is generating inside material due to deformation is a intermolecular force or interatomic force. This is an electromagnetic force. Electromagnetic force. In universe, if we categorize all kind of forces, there are 4 kind of forces: gravitation force, strong nuclear force, weak nuclear force, and electromagnetic force. This strong nuclear and weak nuclear are observable only within the nuclear dimensions, only within the size of nucleus, that is Fermi meter or 10⁻⁻15 meter. We cannot observe nuclear forces outside nucleus. Okay, the nuclear forces are short range force. So this restoring force that we are observing within a material is not a force between the nucleuses. It's force outside the nucleus. It's a force between atoms or molecules. It's a type of electromagnetic force. It is neither a gravitation force. It's a type of electromagnetic force. So we are talking about restoring force. This is due to deformation. When materials deform, the distance between atoms and molecules are changing. So this decrement in distance or increment in distance causes some force to generate between molecule, and that force is restoring force. Okay. If we will learn one more point about restoring force. Let's say I am having a rod here and I am applying 2 forces at the ends of the rod. There is a deforming force which is trying to pull the rod. It is applied at both ends. I cannot apply a force at one end and try to elongate a rod. If I want to elongate this pen, I need to pull this by both the sides. No? Only by applying force by both the sides, I am able to pull this. So I am applying forces at both the ends. This yellow colored force is my external deforming force. Because of the two forces, body will not accelerate. It will not accelerate because equal and opposite forces are applied here. Okay, so it will not accelerate. But let us try to imagine cutting the body. I am cutting the body in between, and I will try to observe the 2 parts. I am cutting the body in between. Now I will observe the 2 parts. I am not actually cutting the body. I am trying to imagine that I am cutting the body and the 2 parts obtained are here. These are the 2 parts. Okay, let's name the parts. So I am calling this is part A, this is part B, this is part A, this is part B. On part A, I am applying an external force in this direction, left direction. On part B, there is a force in right direction. In yellow color, I am showing the external deforming force. In yellow color, I am showing the external deforming force. This external deforming force is trying to pull part B in the right direction and part A in the left direction. Okay, part B is going in the right direction because of this external force. Part A is going in this direction. But in reality, if the two parts were together, they are not going anywhere. Two forces are equal and opposite, so they are not going anywhere in reality. So why this part is not moving there? Because there must be some other force which is trying to resist the motion, and that other force is generated by part A. Part A is applying a force on the part B. This is force on part B by A, and there will also be a force on the part A due to part B. There will be some internal force between part A and B. By Newton's third law, this will be equal and opposite. By Newton's third law, this will be equal and opposite. So this is force on part B due to A, this is force on A due to B. These are internal forces. Now, if my part B and part A are not accelerating, they are at rest, they are in equilibrium. In equilibrium, if A is in equilibrium, this F should be equal to this FAB, this F should be equal to FBA. So external deforming force is equal to internal FAB or FBA. These are internal restoring force. Why in equilibrium? I am talking about the situation of equilibrium. When the two parts are not moving or the body is not moving, so we are talking about equilibrium. In equilibrium, the internal force is equal to external force. This is the main point of learning here. The internal force is equal to external force in equilibrium. Check, is this point clear? In equilibrium, the whatever amount of deforming force that we are applying, same will be the internal restoring force. Same will be the internal restoring force. Is this 100% clear? Okay, when I try to pull this pen, I am trying to pull this pen, so my force of pulling here will be equal to force of restoring force generated in the material in equilibrium. If this pen is not going anywhere, in equilibrium, the two forces are equal. So we have talked about deforming force, restoring force. The restoring force is generated within the material, okay, and it is equal to the external deforming force in equilibrium. Now we can learn about stress. Stress. The internal restoring force generated in the material divided by area of cross section is stress. I am denoting stress by sigma. Okay, it is internal restoring force divided by area of cross section. Per unit area, what is the force generated? That is stress. That is stress. But in equilibrium, this is equal to external. So you can also write external force per unit area, but in equilibrium only. Okay. Now unit force by area. Newton, force is measured in Newton, area in meter square. So Newton per meter square, which is also the unit of pressure. Force by area is also pressure. Dimensions. Force by dimensions of pressure will be there. Force by area. So ml minus 1, T minus 2. This is the unit and dimension of stress. Unit and dimension of stress. Why stress is created in the material? Why there is internal restoring force? Because of the deformation. When you try to change the distance between two molecules or atoms within the material, there is some force generated within the material which is called internal restoring force. That internal restoring force per unit area is stress. Why this stress is generated? Because of deformation. Stress is due to deformation or deformation. If deformation is there, then there is strain. What is strain? Now we will define strain. Strain measures the relative deformation. Strain is relative deformation. It is amount of deformation upon original dimension. It is the change in dimension divided by original dimensions. Change in dimensions upon original dimension. If you are trying to increase the length, then change in length upon original length is strain. Okay, so it's ratio of similar physical quantity. It's a ratio of length and length. It's a ratio of length and length. That's why it is unitless and dimensionless. Strain is unitless and dimensionless physical quantity. We have talked about this a lot of time. That strain is unitless and dimensionless. Strain is unitless and dimensionless. So stress is caused by strain. If there is strain, there will be stress. Okay. What is stress? Internal restoring force divided by area. What is strain? Change in length or change in dimension divided by original dimension. Change in size upon original size. There are three different types of stress or strain observed in material. Next, write down types of stress or strain. You will say there are different types of stress in life. Some has stress of getting selected in NEET, some has stress of getting selected in IIT, some has stress of studies, some has stress of something else, some has stress of something else. Okay, so in life, it's just like life, there are different types of stress. Here also we have, in physics also we have three types of stress and stress, three types of stress and strain. Okay, let's come back to physics. Okay, enough of the chit chat. Types of stress and strain. Okay, stress. There are three types of stress. First is longitudinal. Longitudinal stress and stress. Stress and strain. If we try to elongate a body, then there is tensile or elongative stress or strain. If we try to compress it, there is compressive stress and strain. Okay, so suppose I have a long rod here, and I am trying to pull the rod from both the ends. I am trying to pull the rod by both the ends. Because of this pulling force, the length of the rod may increase. So suppose initial length was L. So after the force is applied, length is increasing. After force is applied, length is increasing. So new length is, let's say, N plus delta M. So let's say we are applying force on this rod, and due to the force, length is increased. Due to force, length is increased. Okay. In this situation, there is a tensile or elongative stress. Or suppose you try to decrease the length by applying force, which is pushing the rod inside. Let's say length of the rod is decreased due to the force which is trying to push the rod. In this case, there is compressive strain. In both the situation, the strain developed in the material, is longitudinal or longitudinal strain, and that is defined as magnitude of change in length upon original length. Magnitude of change in length upon original length. Why I am putting a magnitude there? Why I am putting a magnitude sign there? Because length change can be negative as well as positive. So by putting magnitude, I am making it sure that our longitudinal strain is positive. Okay, if there is longitudinal strain, if you change the length by decreasing or increasing, then there will be stress developed in the material. The force developed within the material, the internal force developed within the material perpendicular to area. Divided by area. This is called longitudinal strain. This is called longitudinal stress. Okay, I am talking about perpendicular force generated within the material. So suppose I show you the cross section area of the rod here. This rod has a cross section area. Let's say the cross section area is A. The cross section area is A. The cross section area is A. Then the force generated within the material divided by area, that will be stress. But we have already understood in equilibrium, external force is equal to internal force. So external force perpendicular by area. This will also do if you are talking about equilibrium. Okay, is this clear? So first type of stress or strain we were talking about. First type of stress or strain we are talking about longitudinal stress or strain. Longitudinal stress or strain. Okay, it is the force applied perpendicular to area divided by area. This is longitudinal stress, and change in length upon original length. This is longitudinal strain. Okay, so when length changes there, longitudinal stress and strain will be used. But sometimes you try to squeeze an object. So second type of stress or strain, bulk stress or strain. Bulk stress or strain. We all, every human being and every object here is under atmospheric pressure. We all are under atmospheric pressure. There is a pressure of about 1.01 into 10 power 5 Pascal on each one of us. There is atmospheric pressure of each one of us. Due to the atmospheric pressure, object already is sustaining that atmospheric pressure. But suppose you want to increase this pressure. Let's say pressure is increased. Let's say pressure is increased to P naught plus some extra pressure is there. We are changing the pressure. We are increasing the pressure. Some extra pressure I am applying. I am increasing the pressure. Some extra pressure I am applying. Okay. So if I increase the pressure, then I am increasing the stress in the material. Whatever is the extra pressure I am applying, that will cause the object shape to change or size to change. Now, due to this extra pressure, the object is squeezed. You can see it here. Due to the extra pressure, object is squeezed. Due to the extra pressure, object is squeezed. So this was our original object. In dotted line, I am showing you the original object. Okay, and due to the extra pressure, object is squeezed. So change in increment in pressure is causing some extra force. Then extra force, I am showing that extra force here by the arrows. This is not this. This is sphere. This is sphere. This is a sphere. Sphere of volume. Let's say initial volume is V. I am showing the volume of sphere to be V. Volume of sphere is V. Okay. So due to increase in pressure, the volume is decreasement. Due to increase in pressure, the volume is decrease. The new volume, let's say, is V minus delta V. The new volume is V minus delta V. Whatever is the decrement in the volume divided by original volume, that is called volume strain. Bulk stress or strain, or we also say this volume stress or strain. Volume stress or strain. So volume stress or strain is negative of change in volume divided by original volume. Negative of change in volume upon original volume. When we try to squeeze a material by applying pressure on it, by increasing the pressure, the volume is getting reduced. Whatever is the amount of reduction in the volume, that reduction divided by original volume, this is called volume strain. Why I am putting a negative sign here? Because volume change is negative. Change in volume is negative, so by putting a negative sign, volume change will become positive. By negative sign, the strain will become positive. So volume strain or bulk strain is negative of change in volume upon original volume. Why this is happening? Because of the increment in pressure. The increase in pressure, whatever amount of pressure you are increasing, that is nothing but bulk stress or volume stress. It is change in pressure. It is an increment or change in pressure. Increment or change in pressure. If you increase the pressure, volume of object gets reduced. Okay, how we can increase the pressure? You can take this object to some depth in liquid. We all know in H depth in liquid of density rho, if we take an object to a depth of liquid, let's say we are taking in H depth, the change in pressure is H rho G. So this kind of question can be asked to you. Okay, they will say that I am taking a ball to, let's say, 50-meter deep in water. What is the amount of stress in the ball? What is the amount of stress in the ball? So that stress can be just change in pressure, and that is H rho G. Okay, and we should also remember the 1 atmospheric pressure. 1 atm pressure is 760 mm of Hg, or this is also 10 meter of water. Approx 10 meter. Okay, if you take a ball to 10 meter deep inside water, the change in pressure will be 1 atm, or nearly 1.01 into 10 power 5 Pascal. 1.01 into 10 power 5 Pascal. So when we take an object within a liquid, the pressure change will be H rho G. If I take the object to 76 centimeter of Hg, 760 mm is also 76 centimeter. So if I take a ball to a depth of 76 centimeter in mercury, then if the vertical depth is 76, then the change in pressure is equal to 1 atm. So if they ask you what is the stress developed, it is just 1 atm, or 1.01 10 power 5 Pascal. Okay, so if we know this, we can solve some questions. Is this clear? We have discussed about 2 types of stress. Okay, is this 2 types of stress are clear? Tell me. Shyam, Anand, is this clear? Very good. Okay. So we have discussed about 2 types of stress till now. Let us go to third type of stress. Third type of stress or strain. Third type of stress is strain, which is called shear stress and strain. We are not discussing shear stress and strain. Shear stress and strain. Suppose if I hold this pen very rigidly at the base, I am holding it very rigidly here. Then I am applying a force at the top like this. I am applying a force at the top. If you apply a force at the top, if your force is large enough, there will be a bending. So I am taking a cuboidal object here. And I am fixing the base. Okay, let's say the area here, the cross section area here, this cross section area is A. Okay, now I am going to apply some force on it. I am taking this object, and due to the force, whatever is happening, I am showing it here. Okay, due to the force, whatever is happening, I am showing it here. Okay, so I am applying a force which is parallel to this surface. I am applying a force on object which is parallel to the surface. Can you see? I am applying a force which is parallel to the surface. In this situation, when we apply a force parallel to surface, there is shear stress developed in the material. Shear stress, sigma S. And that sigma S is force applied parallel divided by area. Actually, it is force generated, restoring force generated in the material divided by area. But we always talk about equilibrium situation. In equilibrium, the force will be equal to internal force. The parallel force will be equal to internal parallel force. So this is the stress generated in the material. Due to the stress, what will happen? Due to the strain, what kind of strain is happening here? Let us first understand what will happen if we apply this kind of force here. So I'm making this initial diagram with dotted line. So material shape is changing now. So to change the shape, I'm changing the initial shape. My new shape of material is somewhat this. It is shifted slightly. In the green color, I'm showing the new shape of the material. In the green color, I am showing the new shape of the material. Okay. Because of the shear force, object is tilted a little bit. And you can see this tilt very easily in some materials. I am not getting any material here for which I can show you the tilt. Okay. Just a minute, let me check. There are some boards here, but these are very small, so I won't be able to tilt those. Okay, I don't want to harm this pen, otherwise how will I write here? Okay, so there is nothing here which can be easily tilted. So just imagine there is nothing here. Okay, I was trying hard to find something which can be tilted, but I am not able to find anything here which is easily tilted. Okay, so let's just imagine. Okay, if we try to apply a force of this kind, you can tilt any object in your home. Okay, you can take a straight plank, a board of plastic or board of wood. Okay, flexible board. Okay, and book. I don't have a book here. I was searching for the book, but I don't have a book here. Okay, if you take a book and try to apply a force like this, then the book will be tilted. The amount of tilt is measured by the shifting here. You can see there is some shifting of the top face with respect to the base. Whatever is the distance by which this top surface is shifted, divided by the height, this delta x by height, this is called shear strain. Shear strain is defined by the shift because of the force, shift divided by height. And the same, if I say this angle is theta, same is tan theta. Whatever is the shifting here, delta x divided by height, that is also tan theta. Tan theta is perpendicular upon base. So this is also tan theta. And see, usually angle is very small, so tan theta can be also written as theta. So this theta, the angle by which object is tilted, is also called shear angle. Shear angle or angle of shear. Shear angle or angle of shear. Okay, so when you apply tangential force to the surface, object's upper face shifted parallel to the base surface, the amount of shift divided by height, that is called shear stress. Okay, so we have now discussed about the three types of stress and strain. Now I will tell you a very simple concept, very important and simple concept. This is not a type of stress, this is limit of stress. Write down breaking stress. We all must have seen that when we apply large enough force, usually object breaks. Okay, if I try to break this pen, I'm able to break this. Okay, it is breakable, but in order to break it, I need to apply large force. With large force, there will be large stress in the material, and if the stress in material increases up to the breaking stress, material breaks. So the stress at which material breaks, it is the stress in material at which object will break. Okay, in some question this breaking stress is given to you. Sometime. It's sometime given. Then they will ask you what is the breaking force. Breaking stress will be breaking force upon area of cross section. Hence, breaking force will be breaking stress into area. More the area of cross section, more force is required to break the object. That's why when you have thick material, it's difficult to break it. If I have thick plastic sheet, it will be difficult to break it. We have plastic chairs here. We have plastic chairs here. Okay. So if I see this thickness, if this thickness is more, it will be difficult to break. In very cheap or very cheap quality chairs, the thickness will be less. That's why they are easily damaged. Okay, so more cross section area, more will be the force required to break the material. Okay, with the same material, if you increase the area, more force will be required. So material will be stronger or sturdier. Okay, so we have discussed one concept of the breaking stress. Now one more important concept we need to study. Write down torsion. Torsion or twist. Torsion or twist. Torsion or twist. This is T. Sometimes I write T like this. Top. Okay. Torsion or twist. Torsion or twist. What is torsion? Torsion. Suppose I try to twist a body. I will show you the twist. I have plastic. I have this paper plates here. Okay. I am going to use this to show you the concept of torsion. Okay. So I will try to create a strip out of this. So see, now I have created a strip out of this. Can you see? This is a strip. Okay, I am creating a strip out of this. Okay, if I keep the top surface fixed, and I try to apply some torque, and I try to apply the torque at the base, I am trying to apply some torque. See here. I am trying to apply torque here. Due to the torque, the lower surface is tilting. It is getting some angle. It is shifting by some angle. See, my two fingers are fixed here, and my two fingers I am rotating by 90 degrees. I am 90 degrees. Then what is happening here? There is twist in the material. What is happening here? There is twist in the material. We say there is a twisting in the material. And by whatever angle the lower surface is tilted or rotated with respect to upper surface, that is called angle of twist. That is called angle of twist. Okay, so twist or torsion, we are going to study twist or torsion. So let us imagine that we are having a cylinder here, and I am fixing the cylinder with some upper rigid wall. I am fixing the cylinder with some upper rigid wall. Okay, I am fixing a cylinder here. Okay, let us change the color of cylinder. So I will draw the cylinder with blue color. So I have a cylinder here, and I have fixed the top of cylinder. I have fixed the top of cylinder with a rigid material, with a rigid surface, Let's say we have a rigid wall, and I am fixing my cylinder to the rigid wall. I am fixing my cylinder to the rigid wall. Okay, I fixed a cylinder to the rigid wall. After fixing the upper surface of cylinder, I am trying to rotate it. I am holding the cylinder like this, and I am trying to give it a twist. So to give it a twist, I am applying an external torque. So I am showing here external torque, which is trying to causing twist or torsion. I am showing you an external torque which is trying to twist or torsion in the material. Because of that, let us imagine there is a straight line. There was a straight line on this cylinder. And because of this external torque, it is twisted. The cylinder is twisted. So the top of the line is still there, but at the bottom it is slightly shifted. So the angle by which this line is getting shifted, that angle is called angle of twist. The angle, I am showing that angle by phi here. So phi is angle of twist. It is the angle by which the base of the cylinder is getting twisted with respect to upper surface. The upper surface is fixed and the base of the cylinder is getting some shift. some rotation is there. So I'm trying to rotate the cylinder. Whatever is the amount of rotation here, that is angle of twist. Due to this angle of twist, there is some shifting. If you see properly, let us take this pink color. There is some shifting of this point. The point A, which was here, now it is shifted to here. Point A is shifted. The amount of shifting of point A, let's say radius of the cylinder is R. The radius of cylinder is R. R is radius of cylinder. And L is height of cylinder. Okay, so if R is radius of cylinder, this is R radius of cylinder, then this shifting of object delta x, that will be angle of twist into R. Angle of twist into R. We all know the arc length is radius into angle. So radius of cylinder R into angle of twist, this is going to shift. This is going to give you shift. And if I know the shift and the height of cylinder, I can know the shear angle. The angle created here is shear angle. The angle created here is shear angle. So angle of shear is this red color visible? Angle of shear, the shear angle theta will be the shifting delta x divided by height L. The shifting delta x divided by height L. And what is the amount of shifting here? That was phi into R. Phi into R divided by L. So now I have a relation between angle of shear, which is R by L, into angle of twist. So this is angle of shear and this is angle of twist. Because of twist, there is some shear strain generated in the material. So what is the amount of shear strain? That can be derived if I know the angle of twist. This is the relationship between these two. Note this relationship between these two. Relationship between angle of shear and angle of twist. Okay, and there is one more important concept involved here. Let us also cover that concept along with this. When we rotate the lower surface, we are applying an external torque. Because of this external torque, there will be an internal restoring torque. Let's say tau is internal restoring torque. That internal restoring torque generated in the material is proportional to angle of twist. I am using phi for angle of twist here. So let me show phi here. Internal restoring torque generated in the material is proportional to angle of twist, and the angle of and the proportionality constant that we apply here, C, proportionality constant that we apply here, C, is called torsional constant. Torsional constant. When you try to twist a material, there is an internal torque developed in the material. The internal torque developed in the material is proportional to angle of twist, and that angle of proportionality constant is called torsional constant. So this was the important point that we have to discuss here. It is a theoretical point. Okay, it's observable when you try to twist a material, there is an internal torque developed. So that internal torque is trying to regain the shape. For example, this paper is also, when I am trying to twist it, if I leave it, it is regaining its shape, original shape. Why it is regaining its original shape? Because of the internal restoring torque. Okay. Yes. You can also say this is also torque generated per unit angle of twist. Okay. So today we have tried to discuss some theoretical concepts of elasticity. We have discussed about stress, strain, torsion, and breaking stress. Before that, we have discussed about restoring force, deformation force, elasticity, plasticity, etc. Okay. try to read NCERT. In NCERT, you will find some extra information. I will cover all the information, but with some due time. Okay, so try to read NCERT. If you read NCERT of theoretical topics, the topics will be understood in a better way. Okay, so let us stop here. Okay, I have a next class and time is over. So we will meet in next class. Thank you all of you. Take care.